Hi class, so we're going to begin with 14.2. This is acids and bases, acids and properties and examples. So we're just barely going to introduce acids. So acids have been used in spy movies. If you've ever seen a lot of stuff, acids are used and over exaggerated to an extent in a lot of things. I'm not going to go into detail with things that I've seen in horror films and stuff, but acids can dissolve certain metals, and this picture is a picture of a person with acid dissolving a bar, which actually would take more than what that person has in his hand. So acids have a sour taste. So you think of a lemon. Lemon is very sour. They dissolve many metals, and they can turn blue litmus paper red. So if we had been in class, in lab, you would have had litmus paper that is blue and litmus paper that is red. The blue paper is basic, so I'm going to show you here. Blue litmus paper is basic, and when dipped in a solution that's acidic, it will immediately turn red, but it actually looks kind of pink. And red litmus paper is acidic, and if you want to test a basic solution, you would dip this in and it would turn blue. Now, obviously, if you dip red litmus paper into an acidic solution, nothing happens, and blue litmus paper in basic solution, nothing happens. Had we been in lab and you would have had to do some labs, you would have had to prepare or check for certain acidity or a basic solution. So that's what they mean when acids turn blue litmus paper red. So you see the lemon, somebody put a blue paper and you can see that's red. I also found this picture online of an apple. An apple is acidic as well. So examples of hydrochloric acid. Hydrochloric acid is a strong acid. It means it completely dissociates, ionizes in water. It does not come back together. And it's used in various things. It's used a lot. It is mainly in our stomach acid. It's what breaks down our food, and it's what gives you heartburn if you have an overabundance of acid in your stomach. Muriatic acid is diluted HCl. If you have a pool or you have done some housework outside, household stuff, it can clean concrete. It can clean off rust. It can do a lot of stuff. So muriatic acid, they sell it all over the place. It's just very diluted hydrochloric acid. Another examples of acid are sulfuric and nitric acid. Sulfuric acid is what is contained in most automobile batteries. And it's actually the most widely produced chemical in the United States. I did not explain about myself, but I work in a lab and we work with sulfuric acid a lot. Acetic acid, everybody should have an idea of what acetic acid is. It's vinegar. That's how you would mostly associate it with. But acetic acid is in water, and when it's in water, it becomes vinegar. And how we know it, that sour taste that you have from the vinegar, that's the acetic acid that you're actually tasting. It's a weak acid, which means it doesn't completely break apart. Very few, I'll go into that, but it doesn't break apart the way that hydrochloric acid would. And it has a carboxylic acid on it. Your book is bringing this in. This is not something I'm going to ask you guys to know. This is going towards organic chemistry, but if you're going into organic chemistry, here's a little bit. It has the common groups. So when you see a COOH, what this means is that it has a double bond to an oxygen, a single bond to an oxygen, and then the H that's over here is attached to the oxygen. That's why it's in this the way that it's spelled out on here. I can't think of the word right now. And as for these molecules, one thing I wanted to point out that chemistry tries to keep this kind of across the board. So red is oxygen, white is hydrogen, yellow is sulfur, and blue is nitrogen, and then there's others that are green and so forth, and if they don't have them, then they substitute them. But they try to keep them consistent. So as you see, chloride here is green and hydrogen's white. These are what the molecules are looking like, and their shape, their geometric shape and form, so that's what you can see in bubble. Had you been in lab, you also would have had these little balls and sticks, and you would have put these together to see the actual shape and understand the geometry of them. But you would have had the balls as orange, oxygen is red, white, you would have followed the same thing. It would have given this to you. So that's what you're seeing here is these weird kind of bulbous molecules are what these compounds look like in the geometry. And carboxylic acid, a lot of acids, many acids contain this carboxylic group in them. And what it is that they all have this, and then where this line comes out, this is what changes. So for acetic acid, you see it has a carbon and 3 hydrogens around it. So it'll be a methyl group, which would be methane, but it's a methyl group. And then there are more carboxylic acids, but they don't show you, but more, 2 of them included here are citric acid and malic acid. So this is just an introduction to what acids are. And that's it.